rrteaching6278 ఛానల్ నుండి
అండి అందరికీ నమస్తే. ఈరోజు మనము ఈ వీడియోలో అబౌట్ ఇర్రేషనల్స్ ఎక్సర్సైజ్ 1.2 and also theorem 1.2. So first of all, theorem 1.2 means what is given here. Let p be a prime number. P is one of the letter. It is be a prime number. If p divides a square, then a divides a. Sorry, p divides a. P divides a square. Then p is also divides a, where a is one of the positive integer. Now let's go to the proof. Let prime factorization of a as follow like this. Here a is equal to p1, p2 and so on pn. So then suppose squaring on both sides. Suppose we square this, a square is equal to p1, p2 and so on pn. So a square means a into a. Now this one square means 2 times we are writing 2 multiplication. Now a square is equal to, when it is squaring it, p1 into p1, p1 square, p2 into p2, p2 square, pn into pn, pn square. So here let us think about fundamental theorem of arithmetic. So what is fundamental theorem of arithmetic? Every composite number can be expressed as a product of primes. So according to uniqueness of fundamental theorem, a square or p1, p2 dash 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 pn are the prime numbers. So p is one of the letter in p1, p2 and so on pn. Since a is equal to p1, p2 and so on pn, p divides a. This is the fundamental. By using fundamental theorem, we can prove this. Let p divides a. P divides a. One second. So here a square is equal to, how can we multiply to get p1 square and p2 square and pn square. Okay. Similarly, according to the fundamental theorem of arithmetic, the said every composite number can be a factor of prime number, can be expressed as a factor of prime number. Here p is one of the prime number. P is one of the prime number. That means a square are the prime numbers are p1, p2 and so on pn. So p is one of the p1, p2 in pn. Since a is equal to p1, p2 and so on pn, and p divides here. So let us take some questions to prove the irrational. So in the exercise 1.2. So before 1.2, we are going to, let's take an example of root 2. Prove that root 2 is irrational. Prove that root 2 is irrational. When it is irrational, for this we are taking, first we are taking root 2 is a rational. If we can prove root 2 is rational, if it is not possible, it is a irrational. So, but what is the definition of irrational? Irrational means numbers cannot be expressed as not expressed in the form of p by q. Numbers cannot be expressed in the form of p by q. That numbers are called irrational numbers. So first let us assume root 2 is rational. Numbers cannot be expressed in the form of p by q are called irrational number. Numbers can be expressed in the form of p by q are called rational number. When we assume root 2 is a rational, now that is root 2 can be written in the form of p by q. Take any of the letter x by y. Here I am taking x by y because rational number can be written in the form of x by y. Now squaring on both sides, When squaring on both sides, square root of whole square is equal to x by y whole square. Now square and square root cancel. We have 2 this side, and here we go x square by y square whole square. A by b whole power m form identity. A by b whole power m is equal to a power m by b power m. So here we go. I'm interchanging the values here. Suppose y square or 2y square, this y square comes here, is equal to x square. Say it is equation number 1. Then y square is equal to x square by 2. X square by 2. You observe here, x square is divisible by 2. X square is divisible by 2. When x square is divisible by 2, x is also, therefore, x is also divisible by 2. Okay, so it is clear that according to uniqueness of fundamental theorem, then take x is equal to any of the letter 2k is some value, k is some value. Substitution this value in the equation 1. Now, what is equation 1? 2y square is equal to x square. In the x place, I am replacing the value 2k whole square. Here, 2y square is equal to 2 square means 4k square. Okay, when it is clear that k square is equal to 2y square by 4. 2y square by 4. Now, interchanging that values here I am writing to go. So, k square is equal to 2y square by 4. 2 ones are 2 twos are. K square is equal to y square by 2. When k square is equal to y square by 2, same here is as it is like this. Y square is divisible by 2. Y is also divisible by 2. See, I am taking here x and y. Here x and y are co-primes. Y are co-primes. What is co-prime definition of? Co-primes means when the numbers are co-primes, their common factor is 1. When their common factor is 1, highest common factor is 1, the two numbers are said to be co-prime numbers. So, but you observe here, the common factor of both these x and y has x has divisible by 2 and y also divisible by 2. So, other than 1, so root 2 is, we can say that here 2 has the common factor. 2 has common factor of x and y. Thus, our contradiction, actually we want to common factor 1. When it is a common factor 1, it becomes a rational number. So, I am taking contradiction. Our contradicts root 2 is irrational or not rational. So, what is that? Root 2 is, therefore, root 2 is, we conclude that root 2 is irrational. So, once again clearly you understood this. Root 2 is equal to x by y. Why I am taking x by y? I am assuming here root 2 is a rational. So, now x and y. Then squaring on both sides. Here x and y are co-prime numbers. Square root cancel. X square y square root. 2 is equal to x square by y square root. 2y square is equal to x square root. Y square is equal to, this 2 goes to the denominator, x square by 2. So x square is divisible by 2. X is also divisible by 2. For example, suppose 2 square by 2, that means 4 by 2. 2 ones are 2 twos are. Suppose 2 by 2 also divisible. 2 ones are 1. So, when square is divisible by 2, then the number is also divisible by 2. X is also divisible by 2. Similarly, take x is equal to 2k. Substitute this value in the equation 1. In the x place, 2k, but it is a square is there here. So, 2k whole square. 2k whole square is 4k square. Now, 4 goes to the denominator and 2y square by 4. And rearranging these values, k square is equal to 2y square by 4. 2 ones are 2 twos are. And k square is equal to y square by 2. When it is a y square by 2, then y square is same just like y square is divisible by 2, y is also divisible by 2. So 2 has common factor of x and y. Here common factor is 2, here also 2, x is also 2. That is why we can't get 1 now. So I am taking x is a rational number, he is not a rational number. So our contradiction is wrong. So root 2 is irrational. We conclude that root 2 is irrational. Similarly, root 3 also as that, but we are taking 2k here, but root 3 means we are taking 3k, where it is 3k. So now root 5, we want to prove root 5. So by using this scenario, we can prove root 5 is irrational. Let us assume root 5 is a rational first. When it is a rational and root 5 is equal to x by y, x and y are co-prime numbers. Now applying the values 5 here. So only changing the value 5. 5 is equal to x square by y square. Therefore 5y square is equal to x square. Then it becomes 5. So here x square is divisible by 5. X is also divisible by 5. See, you observe here carefully, you are getting that result. same as it is like that. Here I'm taking a 5 because it is a root 5, I'm taking a 5. If you have a root 2, you take a 2k, I mean 3k. Root 3 means 3k, root 2 means 2k. Then here it is applying the value in the equation 1, 5y square is equal to 5k square. 5y square is equal to 5 5s are 25, and 5y square is equal to 5y square by 25. 5 ones are 5 5s are. So here it is like this, 5 by 25. 5 ones are 5 5s are. So I have here it is a 5. Y square is divisible by 5. Y is also divisible by 5. Then here common factor is 5. So no common factor 1. In fact, that x and y factor x and y. So that's our contradicts root 5 is not rational. So root 5 is irrational. See, only changing the values. All are very easy method. One you learn means. So next we want to prove that 3 plus 2 root 5. 3 plus 2 root 5 is irrational. We want to prove 3 plus 2 root. So same way we are using here. 3 plus 2 root 5 is rational. Let us assume 3 plus 2 root 5 is a rational number. Now 3 plus 2 root 5. I'm erasing on this, squaring and cos anything not there. Wait some time. See, this is the question number 2 in exercise 1.2. Okay, right. 3 plus 2 root 5 is equal to x by y. Now 2 root 5 is equal to x by y. 3 goes to minus 3. Because here it is a plus, this goes to minus 3. Now I'm sending 2 is also that side. Root 5 is equal to x minus x by y minus 3 and y overall by 2. This value by 2. And it is you take this as root 5 is equal to 1 by 2 x by y minus 3. Also same as it. This is also same and this is also same. Now here x and y, here x and y are integers. When it is a integers, therefore 1 by 2 x by y minus 3 is rational. When it is rational, when x and y are integers, this value become a rational. When it is a rational, rational is equal to root 5 also rational. Therefore, root 5 also rational. We proved previous, but the contradicts in fact means in the next just before we proved in fact that root 5 is irrational. Just we have proved before. So hence we conclude that 3 plus 2 root 5 is irrational. See here, clearly observe 2 root 5 is equal to x by y minus 3 and 2 goes to 1 by 2. Actually x and y are integers, so thus when it is x and y integers, thus 1 by 2 x by y minus 3 is rational. Therefore root 5 is also, because this is a rational, this is a, which is equal to root 5, you know, that's why it is also a rational. So there's but the contradicts in fact that already we proved root 5 is irrational. When the root 5 is irrational, our question is also irrational. So our contradiction, our assumption is wrong. So what is actually our assumption is rational, but it is a irrational. So our assumption wrong. So in the third question, first one. So third question, first one. Prove that 1 by root 2 is irrational. So let us assume 1 by root 2 is a rational number. When 1 by root 2 is a rational number, 1 by root 2 is equal to x by y. Now reciprocal of this number, root 2 by 1 is equal to y by x. X by y become y by x. So here x and y are integers. Thus root 2 is rational. Root 2 is rational. Therefore here no, this step no, this steps. only, but that contradicts in fact that root 2 is irrational, already we proved. Hence, we conclude that 1 by root 2 is irrational. Okay, so understood here. Here x and y are integers, so root 2 is rational. Root 2 is rational, but the contradicts for which the contradicts in fact that root 2 is irrational. Hence, we conclude that 1 by root 2 is irrational. So very simple answers is that. The next question is the question number 7 root 5. 7 root 5 is a irrational. We want to prove 7 root 5 is irrational. Let us assume 7 root 5 is rational. Here we go applying that 7 root 5 is equal to x by y. Now here in multiplication to get root 5 is equal to x by 7y. So same x and y are integers, then thus x by 7y is rational, therefore root 5 also rational, but the contradicts in fact that root 5 is irrational, already we proved. Hence we conclude that 7 root 5 is irrational. So this is an easy method to follow this question. If you have any doubts, so please comment in comment section about this. Any guidance also give me to change my way of teaching also. Last question in this exercise, 6 plus root 2. 6 plus root 2. So let us assume 6 plus root 2 is a rational number. Therefore, 6 plus root 2 is equal to x by y. Root 2 is equal to x by y minus 6. So, same x and y are integers. Therefore, x by y minus 6 is a rational number. Therefore, root 2 is also rational number, but the contradicts in fact root 2 is irrational. Hence, we conclude that 6 plus root 2 is irrational. So, this is the real number chapter in 10th class. Real number chapter in 10th class. Chapter number is 1. AP syllabus. 2025, 24, 25. Okay, so you understood my way of teaching. You please comment section, and what are the changes in my way of teaching, and also uh, any remarks is there, please tell me in the comment section. Thank you. Thank you. Have a nice day.